Now we'll start with the next type of engineering curve, which is involute. I'll define the involute while solving the problem itself. So first I'll read the problem. Draw an involute of a circle 60 mm diameter. Also draw the normal and tangent at a point on the curve at a distance 120 mm from the center of the circle. Now first forget about this normal and tangent part. I'll first draw the involute of a circle of 60 mm diameter. So first I'll start with drawing a circle of 60 mm diameter. For that I'll first draw a horizontal line. Then I'll mark vertical diameter for the circle. The diameter given here for this particular problem is 60 mm. So I'll mark the length of the perpendicular as 60. When marking the center at 30, I'll draw the circle of 60 mm diameter. Okay. Now if we see the definition of involute, it says involute is defined as a curve traced by the end point of a thread while winding along the circumference of a circle. Means if I take a thread of some length and if I attach one end here, keeping the one end free, and initially if I am keeping the thread tight, okay, and if I start winding the thread along the circumference, so the some part of the length will start winding along the circumference. So obviously the length available for rotation will go on reducing. So the other end point, which is the free end of the thread, will trace a curve, okay, in this manner, and this curve is called as a involute. Now depending on the length of thread, I can have three cases. First is length equal to the circumference of the circle. So if I take the first case where length of the thread is equal to the circumference, so in that case when the thread is getting completely wounded along the circumference, it will end at the same point because length is equal to the circumference, so it will exactly end at the other end, which is tied initially at this point. So now the second case will be length is less than the circumference. So if the length is less, so while winding along the circumference, it will end before the start point because length is less, so it will end somewhere here only. Again the third case is length of the thread is greater than the circumference. So if the length is greater than the circumference, then after completing one circumference also, some part of the thread will also will be remaining, and it will continue winding for the next revolution, and it will end somewhere here after completing one revolution also. Okay. So here nothing is mentioned about the length of the thread, only diameter of the circle is given. So if nothing is mentioned, we can go for the first case. So here we can calculate the length of the thread. Here it will be circumference, so which is pi d, which is pi into 60. We already calculated this in the previous problem, which is giving me 188.4 mm. So approximately I can take 188 mm. Now the convention is first tie the thread at the bottommost point and keep it horizontal. Obviously we can tie the thread anywhere on the circumference and then start winding, but for convenience we are tying at the bottommost point and keeping initial position as a horizontal line. So I'll mark that length of the thread on this horizontal line, which is 188. which is equal to the circumference of the circle. So I'm taking length equal to 188 along this horizontal line. We'll check once again. Okay, it's 188. So we can show that dimension here. Length equal to C, which is circumference, it is 188 mm. Now obviously the end which is attached to the circle is fixed, so only this end will trace the curve. Let this end be point P. So we need to trace the curve for point P. Now we'll start with the solution. So the first steps for drawing an involute are similar as that of cycloid. So initially we will divide the circle into some equal number of parts. Here again we can go for 8 numbers, and again starting with vertical and then horizontal diameter, obviously dividing into 4 parts. We can further divide by taking angle as 45 degrees. So 45 and then 135. So we'll get 4 more divisions after extending on other half also. Okay. We'll mark these divisions on the circle circumference, starting with 1, 2, 3, 4, 5, 6, 7. Okay, and 8. Now similarly we have to divide this length of the circumference into same number of parts, which is already done for cycloid by using acute angle method. So again we are going to follow the acute angle method, then taking 8 parts random, 8 divisions, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now joining the last division with the end of the thread and drawing the parallel lines. So after drawing the first parallel line, I'll get the division for distance for one division. Now no need to draw the further parallel lines. I'll just take this division as a reference because those are equal divisions, and I'll mark the remaining divisions to get 8 divisions on the length of the thread. Okay. Now here no need to transfer these along the center line because we are drawing involute and not a cycloid. So now I'll name these divisions as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and last is point P. Now this 1/8 division of the circumference is equal to the length equal to 8 to 1 dash. That means after winding the thread for 1/8 division, so this 1 dash will coincide with 1. Similarly, after winding the 2/8 division, this 2 dash will coincide with 2. So this much length will get wound on the circle. But how while doing that, we need to see what curve is traced by P. So for that, I'll first, the method is to draw the tangents at each point. So I'll draw the tangents at each division 1, 2, 3, 4. Now the question is, where to extend these tangents, on this side or on opposite side? Because we are going to get the going to get the point P on this side, so we need to extend the tangents on this side. So at 1 we have drawn the tangent, then at 2 the tangent will be again a vertical line, then at 3 you have to match this diameter from 3 with one edge of the set square, then obviously the other perpendicular of the set square will give you the tangent. Many of you are wasting the time for drawing tangents using protractors. That is not needed. You can use the set square to draw it fast. You have to produce on this manner, in this manner only. I'll tell you the reason why while drawing the curve. So we are producing in one particular direction tangents. We are not producing on both sides because it has some valid reason. I'll explain you. So we are drawing the tangents at each point. At 7, and at 8, this initial horizontal line is nothing but the tangent, so no need to draw at 8 again. So after drawing the tangents at 1, 2, 3 up to 7, the initial length available for rotation is 8 to P, which is this length. But when 1/8, that is this much length, is getting bounded on this 1/8 part of the circumference, this much length will get locked and will not be available for further rotation. So only available length for further rotation starting with point 1 will be 1' to P. So from 1 I need to mark 1' to P distance on this tangent. Okay, this will be the available length for further rotation. Similarly, continuing with same way, after 2/8 rotation, this 2' will coincide with 2, so that means this much length is locked and not available for further rotation. From 2 onwards, the only available length will be 2' to P. So I need to just take this distance and mark for further rotation. So in this way, I am going to trace the point P. So starting with 1, so I am first taking distance equal to 1' P in the compass. Okay. Then with 1 as a center, I'll mark the remaining length which is available for further rotation, and this will give me the first position of point P when 1/8 length of the thread is already bounded. So this point will be denoted by P1 because it is corresponding to point 1. Continuing this way, the length will go, that length of thread will go on reducing by 1/8 division. So after touching at 2, the further length available will be 2' P only. So with 2 as a center, I'll mark available length as 2' P. Then with 3 as a center, length available will be 3' P. This much. With 4, 4' P. With 5, 5' P. With 6, 6' P. With 7, 7' P. Okay. So now, obviously, the last point P, after complete revolution, it will coincide with 8. So we'll continue. For marking P2, I need to extend this tangent of 2 to get P2. If I'm getting P2 here, then for 3, the corresponding point P will be P3, P4, P5, P6 and P7. Obviously corresponding to 8 will be P8. Okay. So we need to join this P2 P1, P2 P1 to P2 by smooth curve. Remember here, many of you do the mistake of joining these points with the compass itself. Like I'll produce the arc with A2P and with using compass. But here remember that the length of thread is continuously reducing. That means your length for further rotation is going to change at each point. So you can't produce the arc using the same length because radius for that arc is not remaining same at each instant. It is continuously reducing. Okay. So you need to join it by smooth curve only. So for that you can either use a French curve or you can draw it by freehand if your freehand drawing is good. So I'm using freehand. It should be a smooth curve. So P2 to P3. For better result, you can divide the circle into more number of parts. So you'll get these points closer. So you can have more points to join. So that will give you more smooth curve. But 8 points still okay. So first draw by smooth curve by light lines. Then obviously P7 and then P8. Okay. Now you can join by making it dark. So first P2 P1, then P1 to P2. It should be smooth. Then P2 to P3. It should be continuous. Then P3 to P4. And P4 to P5. P5 to P6. P6 to P7 and then P8. So this particular curve is called as involute. So you can name the curve as involute. Okay. Again, we need to show the dimensions. We have already shown the length of thread. You can also show the diameter of the circle somewhere here, which is 60. So you can show it like this. Diameter as 60 mm. Now we'll see the next part, which is also draw the normal and tangent at a point on the curve at a distance 120 mm from the center of the circle. Now on this curve we need to locate a point which is 120 mm from the center, and at that point we need to draw the normal and tangent to this particular curve. So first we'll take distance equal to 120 in the compass. Okay, and from the center of the circle I'll check where it is cutting the curve. So obviously it will cut only at the single point, this much. So this point, at this point I need to draw the normal and tangent. So for drawing normal and tangent, the procedure is, after marking that point, Remember, this point is not P3. To avoid the confusion, I'll shift the position of P3. This point P3 is here. Let the point at which we need to draw the tangent and normal be Q. So first step for drawing normal and tangent at Q is, with Q, draw a line up to the center of the circle. Okay. Now as we know, point Q is between P2 and P3. Okay. So with Q to center, that is C, so with CQ as a diameter, I'll draw the semicircle. So for that, first I need to mark the midpoint of QC. First, QC is giving me the length of almost 12 mm. 12 centimeters. So I'll divide exactly at 6. So this will give me the center for QC. So with this as a center, I'll draw the semicircle with QC as a diameter. But again, I can draw the semicircle on this side as well as on this side. But as we know, Q is between 2 and 3. So I should draw the semicircle on this side such that it will cut the original circle between 2 and 3. So after drawing the semicircle, I am getting the division on the circle, original circle, for which we have drawn the involute here. Okay. So this point, from this point, which is the division of semicircle with the circle between 2 and 3, with this point up to Q, if I join, it will give me the normal at point Q. So if I extend this, so this line will be the normal, so I can denote it by NQN. So this will be normal, NQN. And obviously for getting the tangent, I need to draw the perpendicular to this normal at point Q. Somewhere here. So if I extend this perpendicular at Q, I'll get the tangent at Q. So I can denote it as TQT, the tangent, and NQN is the normal. So for drawing the tangent and normal, the procedure is first locate the point where you want to draw the normal and tangent, then join that point with the center of the circle, then with that length as a diameter draw a semicircle. But be careful while drawing the semicircle, we need to draw the semicircle on that side where the point Q is lying. It is lying between 2 and 3, so I need to draw the semicircle such that it will give me the intersection with the original circle between 2 and 3. So that intersection point here, after joining with Q, will give me the normal, that will be denoted as NQN, and drawing the perpendicular to that normal at point Q will give me the tangent. So we have drawn the normal and tangent. So this completes the solution for this particular problem. But similar problem, this particular problem was asked in December 14 for 6 marks. But similar problem was asked in December 15 also. The only difference, we'll read the problem. Draw an involute of a circle 40 mm diameter. Also draw the normal and tangent to this curve at a point 80 mm from the center of the circle. Problem is same, only dimensions are different. Instead of 60 mm, that circle is given as 40 mm diameter, and instead of 120 mm, the position of point for drawing normal and tangent is given as 80 mm. So procedure will be the same. So this completes the solution for involute.